In this video, we are going to look at the definition of a derivative and how to use the definition to find the derivative of a function. Now, many real world phenomena involve changing quantities. So, for example, you can have the speed of a rocket changing, inflation of currency, and the voltage of an electrical signal. In this section of our calculus course, we'll develop the concept of a derivative, which is the mathematical tool for studying the rate at which one quantity changes relative to another. Now, one of the crowning achievements of calculus is its ability to capture continuous motion mathematically, allowing that motion to be analyzed instant by what? Instant. This is a very important keyword, instant by instant. Now, for example, when you look at, let's say, the speed of a rocket, you realize that the speed of the rocket will change as it is moving or as it is in continuous motion, right? So you realize that at a particular instant in the course of the motion, the rate of change of the distance as compared to time will be different as compared to another instant, right? So the idea of a derivative is what we use to analyze the rate of change of a quantity like the speed, which is the distance over time, at a particular instant in the course of motion, right? Now let's look at this on a diagram representation. All right. So let's say we have a graph, right? And then the graph has a curve on it, right? The graph of a curve. So you know that this is our x-axis and this is our y-axis, right? Now let's say we have a curve of this format. Let me use this. We have a curve like this, right? And then our curve is y is equal to what? F of x. That's the function of our curve, right? Now let's locate 2 points on the curve. See this point and this point. Let's name this point P and this point Q. Now on the x-axis, we'll have a value for the point, right? And then let's say this value is x naught, and we'll have a value for this point. Let's say this is x, right? Now same applies on the y-axis. We'll also have a value, right? But let's say we want to find, let's say, the gradient of this particular curve, right? We have located 2 points, and then we'll have to draw a line through the point, right? And then when we draw this line through the point, the name of this line will be a secant line. A secant line is a straight line that intersects a curve at two or more distinct points, right? Now, once we have established the secant line, let's write the value of the coordinates of the y function, right? So this particular side, if this is x naught, then we can say that since y is equal to f of x, then we can say that the value of this particular point on the y-axis will be f of what? X naught. And then for this particular point, its value will be f of what? F of x, right? Now you know that the distance to find the slope of this secant line, this will be the slope, this will be the triangle we are going to use, right? Now we know that we need the rise and then the run. Okay, the rise is the difference between the coordinates on the y-axis, and then the run is the difference between the coordinates on the x-axis. All right, now you know that this side we can see is the same as what? X minus x naught, right? Now let's say this x minus x naught is equal to, let's say, a variable h. Okay, now the same applies to this section. We know that when we want to find the difference between this point and this point on the y-axis, we'll have f of x minus f of x naught. Okay, so now this side will also be f of x minus f of x naught. right? Now to find the slope of this secant line, then we can say that the slope of the secant line, and here the secant line, let me write it well. Now let's say we have the slope of the secant line, right? And then you know that slope can represent it as what? M. Okay, the gradient of the 2 points, which is PQ. That's the slope of the secant line. We can say is a what? The rise over what? Run, which is the same as the change in the y-axis over change in the x, right? So from here we can see change in the y-axis is f of x minus f of x naught all over, we can see x minus x naught, right? But then we have established that our x minus x naught is equal to what? H. So let's name this as an equation 1. With the same analogy, we can also say that then our x will be equal to, then we'll send x naught to the other side of the equation, becomes positive x naught plus h as equation what? 2. So we can substitute this equation 1 and 2 into the slope of the secant line, and we can see that okay, then the slope of the secant line MPQ will be f of what? X. F of x is what? X naught. X is x naught plus h. So we'll have f of x naught plus h minus f of x naught all over x minus x naught, which is what? H. All right. So now this is the slope of our secant line. Now let's look at something related to now differentiation. All right, we said that for a derivative, it allows us to be able to understand the rate of change of a particular variable at a certain instant in the course of motion. Now let's say we have this x value approaching x naught. Then we'll also have our point Q also moving along the curve to approach our point P. All right, now if the secant, so let me clear this off, the point off. Now if this secant line through point PQ approaches a limiting position as our x minus x naught or our h, then let's see, this secant line is approaching x minus x naught, right? So it's coming back. So now we'll have a secant line, a secant line, a secant line. We'll get to a point. Let me clear this so that you get the picture very well. Now we'll get to a point where now the position of the secant line will now be a tangent line. This line is supposed to be straight, okay? This line is supposed to be straight. Let me try as much as possible to make it straight, okay? This is supposed to be a straight line, right? So we'll have a line at the point P, which will represent, a tangent, which will represent a tangent line, okay? So now we'll have this as a tangent line. We'll have this as a tangent line, right? So at the particular instant P, we can say that the derivative of the function will be the slope of the tangent line, and the slope of this tangent line will be the limit as h approaches 0 of the gradient of the secant line, right? So now we can write it as, we can say that now the derivative of the function is the same as the slope of the tangent line. And we are saying that to find the slope of the tangent line, we are going to say that the slope of the tangent line is limit as h approaches 0 of the gradient of the secant line. Our gradient of the secant line is what? This one, right? So you can see f of x naught plus h minus f of x naught all over what? h. All right, so this becomes the slope of our tangent line, right? At a particular instant, one instant in the course of the motion of this curve, we have found our derivative, which helps us to analyze the rate of change of the curve, right? Now we have arrived at this particular equation. Now we can say that, so this is the derivative with respect to what x naught. All right, so generally, if let's say we are asked to find the derivative of a function, so the derivative of a function f of x, then it is given by, then the derivative, let's say f prime of what x, will be equal to limit as h approaches 0. Now since we are using f of x, we are finding the derivative of the function x, or at a point x, then we'll say that f of what, now x naught becomes what, x plus h minus f of what, x all over h. So this becomes our function for finding the derivative of a function f of x, right? So I believe now you get the whole point of where how we are able to arrive at this particular equation to find the derivative, right? And this is what we call the definition of a derivative. Now let's dive into solving some questions using the definition of a derivative. All right, now let's go to, all right, okay, so now our first question is saying that we should find the I think this is supposed to be derivative. All right, so find the derivative of a function f of x is equal to 2x squared minus 16x plus 35 using the definition of a derivative, right? So once they have asked you to use the definition of a derivative, you know that the definition of a derivative, say f prime of x, is given by limit as h approaches 0 of f of x plus h minus f of what, x all over what, h. All right, now we have established that f of x is equal to 2x squared minus 16x plus 35 plus 35. Now to find the, now we know that this is f of x, which they have given us. Now to find f of x plus h, we know that f of x plus h will be equal to, now wherever we see what our value of x, now we replace it what, x plus h. So it becomes 2 into bracket x plus h squared minus 16 into bracket x plus h plus 35. Then this becomes simple algebra, right? You evaluate this one. To evaluate this, you can see that we bring our 2 out. Since it's x plus h all squared, becomes x squared plus 2xh plus h squared. Then 16 will multiply x minus 16x minus 16 will multiply what, h, comes negative 16h plus what, 35. Now we can simplify this expression to get 2. To simplify this expression, we can say that 2 times 2 times x squared becomes 2x squared plus 2 times 2xh becomes 4xh plus 2 times h squared becomes what, 2h squared. Then we have our other expressions, minus 16x minus 16h plus what, 35, right? So now this becomes our expression for f of h of x. Now let's substitute this into our equation. Now to find f prime of what, x, is equal to limit as h approaches 0 of our function f of x plus h. F of x plus h is this, right? Okay, so now it becomes 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35, right? Then minus our f of x. Our question told us that our f of x is what? 2x squared minus 16x plus 35. This expression divided by what? H. Okay, so simple algebra. Now since we have 2x squared minus 2x squared will cancel out, so this can cancel out this, right? So 2x squared can cancel 2x squared. Then we also have negative 16x. Negative 16x minus 16x becomes what? 0. All right, so this can also cancel. Now we have 35. 35 minus 35 becomes 0 as well, right? Now our function results in, you can say f prime of what? X is equal to limit as h approaches 0 of, now the function becomes 4xh plus 2h squared minus 16h all over what? H, right? So from here, algebra, since we have h for each term, we can factorize each out, right? So we can say that f prime of x will be equal to limit as h approaches 0. H comes out, comes 4x plus 2h minus what? 16 all over what? H. Now we can have our h cancelling out, right? This results in f prime of what? X. This becomes f prime of x is equal to limit as h approaches 0 of 4x plus 2h minus what? 16, right? So to evaluate this particular expression, we say that f prime of x is equal to, we do away with the limit, and we are saying that since h is approaching 0, wherever we find h in this expression, we put 0. If we put 0 into this, then we'll come and have f prime of x to be equal to 4x minus 16, and this becomes our final answer for finding the derivative of the function f of x using the definition of a derivative. All right, let's look at the next question for a better understanding of what we are doing. Okay, now the second question says find the equation for the tangent line to the curve y is equal to 2 over x at the point 2, 1 on this curve. All right, now this is saying we should find the equation, the keyword is equation, of the tangent line, right? When we're talking about the tangent line, I spoke to you about how the tangent line is a straight line, right? So now you know that to find the equation of a straight line, we have a formula for it, right? We say that you have a general formula y minus y1 is equal to m into bracket x minus what? X1, right? Where our m is the gradient of that particular function, right? And our y1 was given to us as 1, and then our x1 is what? 2. Okay, so from here we can see that we know our y1 to be what? Since the point was what? 2, 1, our y1 is what? 1, and our x1 is also what? 1, right? Or our value of x is, sorry, 2, right? So we know that our value of x is what? 2, and our value of y is what? 1. Okay, now to find the gradient of a tangent line, we know that the gradient of a tangent line is given by, so gradient of a tangent line, we said that is the same as what? The derivative, and it's given as what? Limit as h approaches 0 of the function f of x plus h minus f of x all over what? H. All right, now since our point is 2 comma 1, we know that our value of x is what? 2, right? So we can rewrite this. We know that our value of x is 2, right? So x is what? 2. And we also know that when we take our y, which is our f of what? 2, we are going to get what? 1, right? I believe you understand this one. It's not anything complex. We are saying that they have given us the point. The point on our curve is 2 comma what? 1, right? So if we are saying that our x-axis is 2, then it means that our y-axis is also 1, right? Our y-axis is the same as what? F of 2, right? To be equal to what? 1. All right. Now from here, we can see that our slope is the limit as h approaches 0 of the function f of, wherever you see x, you put 2, so it becomes 2 plus what? H minus f of what? 2 all over h. So now we are supposed to find the function of f of what? 2 plus x. All right, but then from our question, we said that the curve is y is equal to 2 over x, right? So our curve y is equal to what? 2 over x, right? So from here we can see that then f of 2 plus h will be equal to, wherever we see x, we put what? 2 plus h there. All right, so we come and get 2 over x plus h, and we know from here our f of 2 is what? 1. So f of 2 is what? 1. All right, so from here we can see that the gradient is limit as h approaches 0 of f of 2 plus h, which is what? 2 plus 2 over, sorry, x plus h, minus f of 2, which is what? 1, all divided by what? H, right? Now to solve this particular section, we know that we have 2 over x plus h minus 1, right? So here we can find the LCM. Our LCM is x plus h. Then we can have here x plus h cancels x. We are left with 2 minus 1 will go into x plus h. It becomes what? X plus what? It becomes x plus h, right? So now we come and get 2 minus x plus h all over what? X plus h, all divided by what? H, right? But don't forget that we said our x, the value of our x is what? 2. Okay. Oh, sorry, we made a mistake here. This place is supposed to be 2. You see this x, right? Wherever we see x, we put up 2 plus h. So we are supposed to get here to what? 2. Here becomes 2. Here becomes 2. Here becomes 2. Here becomes 2. And then our final result will be, so from here we can say that we have 2 minus 2 plus h, right? And you know that 2 minus 2 will be negative h, right? Divided by 2 plus what? H, all over this value of what? H. But don't forget the limit. This is limit as h approaches what? 0 of this function. I believe everyone understands up to this point, right? Now let's continue solving to get our value of our slope. Now from here we can see that this can be written as as limit as h approaches 0, then here can be minus h all over what? H into bracket 2 plus what? H, right? I believe you understand this, right? You have brought this 2 plus h down to the denominator because it is divided, right? So from here you know that h will cancel h, then we'll come and then we'll have limit as h approaches 0 of negative, here becomes 1 over 2 plus what? 8. Since we have a negative value, we can bring the negative value outside of the limit, and then we'll have minus limit as h approaches 0 of the function 1 over 2 plus h. Okay, from here we can see that the gradient is negative. Now we can, wherever we see h approaching 0, we put, wherever we see h, we put 0, right? So from here we can say 1 over 2 plus 0, and this becomes negative 1 over 2, right? So now we have found the gradient of the tangent line, right? But the question told us to find the equation of the tangent line. So from here we can see that our equation is what? Y minus y1 is equal to the gradient multiplying x minus what? X1. We told you that our point is 2, 1 from the question. So we can say that then our equation is y minus y1 is what? 1. We have picked one of the points. Okay, they give us the point, a point on a curve. This is it. So y minus y1 is y minus 1 is equal to our gradient. Our gradient is what? Negative 1 over 2 multiplying x minus x1. X1 is what? 2, right? From here we can multiply the 2 with this side of the equation. So we'll come and say 2 times, the LCM is 2. So 2 times y is what? 2y. 2 times negative 1 becomes what? Negative 2 is equal to, then the 2 cancels the 2, right? Because we are multiplying all the sides by 2. Right, so we'll have this 2 cancelling this 2. So it becomes minus into bracket x minus what? 2. So from here you can say 2y minus 2 is equal to negative times x is negative x plus 2, right? So now we can say that if we want to find the value of y, then we can say 2y is equal to negative x plus 2, and we can send this 2 to the other side of the equation. It becomes plus or 2. So 2y is equal to negative x plus 4. So to find the value of y, we can divide all the sides by 2 to get our final equation. Y is equal to negative x over 2 plus 2, and this becomes the equation of a tangent line, right? You see, this is not really complex. All we had to do was to find the gradient of our tangent line, and after finding the gradient of the tangent line, we just plug into our equation for finding the equation of a line, right? And then we find the equation of the tangent line. Let's dive into our last question, and then we'll call this a day. So our last question says that we should find the slopes of the tangent lines to the curve y is equal to square root of x at x equals 1, x equals 4, and x is equal to 9. So we are going to use a definition of the derivative. We know that a slope of our tangent line is given by limit as h approaches 0 f of x plus h minus f of x all over what? H. Now they have given us our f of x. You know that our f of x is the same as our y, and it's a square root of what? X. So to find f of x plus h, it means that wherever we see x, we put x plus what? H. Then from here we can substitute into the original equation, and we can see that limit as h approaches 0, f of x plus h now becomes what? The square root of x plus h minus f of x becomes square root of x all over h, right? Now to solve this, if you notice the square root, you realize that we can only solve this particular algebraic expression by rationalizing the numerator. All right, so to rationalize the numerator, I mean I will multiply both sides by x plus h plus, because the rationalization form of the minus, you bring the plus, right? x plus h plus square root of x. Realize I have not done anything to the equation. This is algebra. This will cancel this, make it 1. Alright. So what you are supposed to do is that from here you can multiply this side by this side and then this by this, right? Now you know that when I notice this one very well, you realize that it is difference of two squares, right? So for difference of two squares, anytime we have a squared minus b squared is equal to a minus b multiplying a plus b. All right, so this is the same thing that is here. You have a minus b to be this one, and then a plus b to be this one. So what you do is that you take the a is what, this whole expression, and then you square it, right? So you can see that this is the same as x plus h. Sorry, this is the same as what, square root of what, x plus h all squared, which will represent our what, our a, minus, and you take our b is square root of x all squared, and divided by this one, also multiply this, so you come and get h into brackets multiplying this, right? Square root of x plus h plus square root of what, x. Right, so from here we can see that limit as h approaches 0 will be this cancels this, and then you come and get x plus h minus this cancelling this, come and get what, x all over h into bracket square root of x plus h plus the square root of what, x. From here you can see that the limit as h approaches 0, now x minus x will cancel out, so we'll have only h all over h into bracket square root of x plus h plus the square root of x. H cancels h, right? So from here you get limit as h approaches 0 of 1 over the square root of x plus h plus the square root of what, x. Now wherever you see h, you put 0, right? So our gradient or our slope becomes 1 over square root of x plus 0 plus square root of x, and this gives us 1 over the square root of x plus the square root of what, x. And then from here we can see that is 1 over, since our sets are alike, we can see that this is the same as what, 2 root what, x. Okay, so now this becomes our slope, right, or our gradient function, right? Now the question asks us to find the slopes of the tangent line to the curve at certain point. Okay, so now they said find the slopes of the tangent line to the curve y is equal to square root of x at x is equal to 1, 4 and 9, right? So from here to find the slope of that tangent line, so you can say that slope at x is equal to what, 1 will be 1 over 2 square root of what, 1, wherever I see x equal to what, 1, comes 1 over 2, because the square root of 1 is what, 1, right? Now slope at x is equal to 4 becomes 1 over 2 square root of, wherever I see x equal to 4, comes 1 over 2 multiplying the square root of 4 is what, 2, comes what, 1 over 4. And then our last point will be slope at x is equal to 9. All right, so it becomes 1 over 2 square root of what, 9. So it becomes 1 over 2 square root of 9 is what, 3, and it becomes 1 over 6, right? So I believe now you understand what a derivative is, and how to use the definition of a derivative to find the derivative of a particular function at an instant. All right. If you found this video helpful, please do well to subscribe so you don't miss out on future content. See you in our next class on calculus.